So, hello guys. Today's video is going to be about Docker. Um, we're going to first get like a formal, a semi-formal definition or a quick cliff notes about what Docker is from Wikipedia. So it says here, Docker is a set of platform as a service products that use OS level virtualization to deliver software in packages called containers. Containers are isolated from one another and bundle their own software, libraries, and configuration files. They can communicate with each other through well-defined channels. All containers are run by a single operating system kernel and therefore use fewer resources than virtual machines. So that's a semi-formal definition of what Docker is. I'm going to get you to think about Docker in terms of something more practical, right? And you can get to that more practical, hands-on definition of Docker or idea of what Docker is when you think about the problems that Docker solves, right? So let me give you quickly my definition. Okay. So Docker is a containerization technology for software. And what I mean by that is Docker allows you to create an environment for applications that they can run in. From the perspective of the application, it cannot differentiate between being in the container or the host operating system. The file system, configuration files, network, and software dependencies are all held in the container for it to operate. So what problems does Docker solve? Docker solves many problems, but I think most people in the tech world will agree the biggest problem Docker addresses is scalability and portability. What do I mean by that? Before Docker came about, if you had a piece of software that you wrote, and you might have wrote this software on, say, for example, distribution of Linux like Red Hat, that software compiled and it ran just fine on your operating system. You made sure you had all the dependencies, all the libraries, the proper kernel version, etc. This, but when it was time to get other users to use that software, they had to install it on their machines. And a lot of times, the users would have problems hunting down dependencies, making sure the right libraries are installed, making sure they're using the right compiler, just making sure all the things that application would need to compile and run, how it did on the developer's machine, that it ran on the user's machine. And that was a pain. It made it hard to go from getting the application installed on one system to thousands of systems, which is a problem that you have at the enterprise level when it's not just your machine or a couple of machines at your house. You might need to get this thing installed across thousands of computers. But with Docker, you could have everything within that container that the application needs to run within the container itself. And from the perspective of the application, everything remains the same. Everything remains constant. So think of it sort of like a bubble for your software, right? Everything inside that bubble is there to help your application run smoothly, regardless of what system it's on. Right? Providing that system has Docker installed, it will run just as intended. Another way to think of it really is I like to think of it in terms of an aquarium. A small aquarium like the one you'd have in your house. You would have a fish inside, of course. You can't have an aquarium without a fish. But you would have the water, you would have fish food, you would have, of course, a machine to pump oxygen, to oxygenate the water, temperature controls, etc. That fish obviously would have a hard time living outside of that aquarium. So the fish inside that fish tank or that aquarium, that's your software. And the water, the food, the machine temperature controls, etc. All those things are dependencies and configurations required for your software to run. All right, so that's a quick working definition, or something you could think of to kind of conceptualize what Docker is. In the next video, we'll be installing Docker. Have a good day, guys.